So now that we found some exact values, you'll find that we're still finding exact values, but in this time under the guise of rewriting and simplifying. So what they're wanting us to do is to express each one of these in terms of theta and x only. So right now you see the sines expressed as a difference, this tangent expressed as a sum, and this cosine, right, is expressed as a difference. So we basically have to take a look at each one of those in particular and rewrite them in terms of their theta and of x respectively. So because we have the sign of a subtraction, we begin this one by using the sign of a difference, and that's basically the sine of the first angle and the cosine of the second. Since it's subtraction, it's a minus the cosine of the first angle and the sine of the second angle. And so at this stage we got to recall what the sine of 5 pi over 6 is. And so that from our unit circle, I think 5 pi over 6 is 150 degrees. So if we just draw a representative right triangle, so we're talking 5 pi over 6 is 150 degrees basically, so we have a 30 degree reference. So we have 1, square root of 3, and 2. So what's the sine at that value? This is 1/2. Right, that's cosine of x. What's the cosine of that value? Well, that's negative square roots of 3 over 2 sine of x. So if we clean this up, I can pull out a half. We got cosine of x. If we subtract a negative, that's a positive square roots of 3 sine of x. And so there's probably the best we can do with regard to that one in terms of rewriting and simplifying. So we rewrote the difference, used our exact values for 5 pi over 6, which is 150 degrees. I used a right triangle to kind of help me remember that, and then we just basically got what we got. For the next one, we have the tangent of a sum. So that is the tangent of the first angle plus the tangent of the second angle, all divided by 1 minus the tangent of the first times the tangent of the second. That's pi over 4. Again, what's nice about pi over 4, that's 1. So we're basically looking at the tangent of x plus 1 and 1 minus the tangent of x. Okay? And so now what we do is we have a quotient. So we got to kind of maybe clear that up. Let's see. What would probably be a nice trick we can do here? Can we clear that out? Alright, well, let's try it out. Let's experiment a little bit. So we'll write this sine. This is sine x over cosine of x plus 1, and we have 1 minus the sine of x cosine of x. So invoking that same trick, I'll multiply both sides by top and bottom by cosine. See where that takes us. We basically, if we distribute here, we get a sine x plus cosine x, and down below if we distribute we get a cosine x minus the sine of x. Okay. The only thing I can kind of think here is to rewrite this with the sine x plus cosine x. Let me rewrite that, cosine x plus sine x, right? And that's not really looking pretty nice. All right, so I would say we'll probably just keep this right there. The reason I'm going to stop here is because I'm looking ahead and I actually see, well, we've actually seen it, so how about we just go for it. So if we distribute up here, we're going to end up with a sine squared x plus a sine x cosine x plus a cosine squared x. And this is all over, we get a cosine squared x minus sine squared x. Alright, and at this stage I know that sine squared plus cosine squared is 1, so we've got that. Alright, and then on the bottom what we have is from previous work, we know that's the cosine of 2x, and again I'm kind of thinking of 5.4, but here's why I'm going to decide to keep it here, because notice I've kind of gone away from, I want things in terms of theta and x, and right here, right, we still have it in x, but now it's 2x. So I've kind of shifted gears to try to get rid of that. So good, kind of some work there, some nice things to see, but at the end of the day, that takes us away from what we want. So it's probably best just to keep that in terms of its tangent x, and we'll just keep the quotient, right? Can't figure out a nice way to get rid of that. So we'll just leave it there. All right. So next one, we got to go back to 5.3. All right, making you think a little bit. What's the cosine of theta minus 30? Well, that guy, right, when we take the cosine of a difference, that was basically the cosine of theta, the cosine of 30, right? And this was a plus the sine of theta, the sine of 30. And the cosine of 30, that we know to be the square root of 3 over 2. Cosine of theta. The sine of 30 is a half sine of theta. And then the best thing I can do here is to take out a half. We get the square root of 3 times the cosine of theta plus the sine of theta. Alright, so pretty much hopefully some nice review of rewriting a sign of a difference. We could have done the sum, rewriting the tangent of a sum or a difference, and then going back and doing a little bit of 5.3. Alright, and that one's kind of a unique one. Perhaps as I think about it a little bit more, maybe I'll cut another video if I figure out a way to simplify that better, but that seems about the best, because if we try to, it turns into a train wreck. So we'll just leave it as is. Alright, so I'll talk with you guys later. We'll go to move on to verifying identities, which just is another way of simplification. But I'll do that in a new video coming soon.